In public safety and forensics, there are a lot of different cases where accurate, comprehensive scene documentation is crucial to telling this story in a way that removes cognitive bias and reveals the truth of what actually happened. One of those is collision reconstruction. Will, you're a trainer and consultant with Collision and Crime Forensic Solutions, as well as a forensic manager and director of the Omaha Police Department's Forensics Investigations Unit, and you've been involved in documenting some really challenging collision investigations with 3D laser scanning. Do you have an example that you can share with us today?
I do, and it illustrates some of the things that we discussed earlier. So what I've got for you here is a case example for an agency on one of the Hawaiian Islands that we deal with. And simplicity and speed of operation was really important to this agency in particular. This particular location has one road that crosses the island, and if you have to shut down a road, it can be a 4 to 5 hour detour for people. And there are a significant number of crashes that they deal with, and this is a good example of one of those crashes. What we're looking at here is some of the reporting that makes our data easily admissible in court from a capture standpoint. I've got a registration report that's produced at the end of the process here that in a global way and then in a very granular way points out the accuracy of the registrations, the degree of overlap, and how well we're complying with known best practices on scene. And then it also gives me a breakdown of some of the other things that we can do on these scenes with our data and with our technology, which is integrate multimedia like images, video, and now even handheld scans from iOS devices with LiDAR, and integrate those things with the scan data to make it a much more immersive or narrative exhibit closer to the things that we saw from Mark. The data itself, if we take a look at it, and the reason I say this alludes to some of the things we talked about earlier, is this is a classroom environment. We had completed one single day of training, and early the next morning in day 2 of training, they had a near fatal crash, single car crash, and 2 occupants, right? Both of whom are seriously critically injured. You don't want these things to happen during training events, but they can be incredibly useful. And so we take that opportunity, and at 6 o'clock the next morning, get this call. I get out of bed early, meet the guys at the scene. They bring their equipment, and we've got 13 scans here that are done in under 50 minutes by a crew of operators that have just a single day of training under their belt. And when you start to look at the quality of data that they were able to capture with that minimal amount of training, it is very impressive. So not only are they able to do this quickly, but we have the kind of data quality that Mark was alluding to earlier that is nearly photorealistic. So as we fly through this scene, couple challenges for experienced laser scanner operators. You can see that there are not a lot of man-made objects along this path. And while we do have trees out there, they're typically, vegetation is not a great surface for automated registrations, and it can be an issue. We had 0 of those problems on scene with this crash investigation. The imagery is fantastic because we've got 5-bracket HDR imaging that is done in less than a minute. And so we can represent well colors, not just that are well lighted and areas that are well lighted, but we have good color representation in the shadows as well. And these are pretty harsh lighting conditions. You can see the angle of the sun here represented by that breakthrough of the sun on the ground there. We're casting long shadows. Can typically be a little bit difficult for folks. Really, the only man-made object in view is this guy who's living in a van next to the road where this crash occurs. So they do a normal investigation on it, mark out their pavement markings that are going to be important for their reconstruction, and begin scanning. Now, I was on site to help them sort through the problem and talk about where scanner positions should be. I think it's important for folks to be able to see how these scanner positions are spaced out. Every one of those blue bubbles that we see on screen there is a scanner setup, and they are about 70 feet or so apart from each other. So if we do that measurement on screen, you can see this one's about 67 feet or 68 feet apart. What's interesting about that, from the perspective of somebody who sees and works with laser scan data, is the density of coverage that we're getting at that spacing. That means not only am I able to do each one of these setups at 1 minute and 51 seconds, but I can do it at a significant distance from a previous scan and still capture good evidence. We're looking at this data in color at the moment, or RGB coloring of the point cloud. But if we switch this over to what a lot of crash reconstructionists will use, which is grayscale, we get rid of some of that color variation and we start to see just how clear that data is halfway in between scanner positions and on black roadway, right, which is not known for being a good reflective surface. One of the other things I think is important to note is scan data out of the RTC360 in particular is incredibly clean. If you're looking at this crash, this vehicle represents what we heard from Mark and what we hear from a lot of operators that are coming from other technologies over to the RTC360, which is that it is very difficult in some cases to tell the difference between what I'm seeing in a point cloud and what I'm seeing in imaging. So if we jump into the panoramic image representation of this scene, and this is a 5K resolution HDR imaging, we can see that that's a good representation of that vehicle. We can see the color of it, we can see the shininess on it, and it appears as a solid surface because it's an image. If we leave that data, that image data, I'm still looking at a nearly solid surface on that vehicle. This is another interesting thing to note. Even in low radius objects, right, very thin objects like this vegetation, I can make out individual fronds in the grass. And this has all kinds of implications for visualization of pavement marks. In the crime scene world, it helps me do shooting reconstructions to a very accurate degree without having to add things to trajectory rods or additional markings or annotations or size adjustments to the object that I'm trying to map. Those kinds of things all contribute to the speed, the completeness, the accuracy, and the probative nature of the data that's being represented. One of the other things that was really interesting to me at this scene, and I haven't seen this very often, even in a lot of the consulting that we do, is you've got an interesting pavement mark here, which is actually an outline. If you see where my cursor is, an outline of one of the passenger doors as this vehicle is rolling over. Not represented real well in the RGB data, but you can see it very clearly in the grayscale. And then to add people's understanding of it, we could have done a video here, but we chose to do a photograph, and I can launch out like a hyperlink the image of that pavement mark, right, as this is rolling over, to help with people's understanding of the scene and to help folks, when they're explaining this to the trier of fact, help them support their reconstructions. Again, I want to stress that this is all captured by folks in the class with a single day of training, and we've got a usable data set that even on its own is going to support the reconstructions that are done and a lot of analysis downstream. And if it ever comes to the point where somebody like Mark needs to be involved to handle some of those really complex representations that we see in video, everybody wants to say video is a silent witness, but it still has a perspective that was misleading in the case we talked about earlier. This data helps overcome some of those misrepresentations in perspective.